Okay, I would like to welcome you all to this webinar on how to use waste heat from data centers. A good discussion with various experts on how we can do it and how we can do it better also in the future. We're very excited about the number of participants. It's great that there's so good interest for the topic, and we look forward to having the discussions with both the panelists and also you in the audience. So let me just introduce the program to begin with. We will have a short introductory speech from myself. Then we'll move on to our good partner from the Danish District Heating Association. And then we'll have two cases on how to use the waste heat, first from Meta and then from Global Connect in Høje-Taastrup. And then we will, at the end of the seminar, we'll have a Q&A with the panel, and you're all very welcome to post your question in the chat box, and we will make sure to have as many of the questions as possible. And if a question from you is not answered, we will distribute them to the panelists, and they can answer them afterwards. But we will do as much as we can to get through all questions. So the panelists with me today, I would also like to welcome you. It's Jesper Koch, who is head of analysts of Danish District Heating Association. It's Anna Ekdahl, who's business development and energy transition expert at Rambøll. And then it's Anders Frick Mathisen, who is the data center director from Global Connect. So a warm welcome to you guys as well. So before I turn over the word to one of our panelists, let me just give you a short introduction from our side. Despite that we from time to time have the discussion here in Denmark that we ought to use more of the waste heat than we do already, we are still at the forefront, and that's important to remember when we are maybe a little bit critical on how far we have gone. We are actually at the forefront, and we have some opportunities in using waste heat that is rather unique, and we should of course work on utilizing that opportunity even better. As Jesper also might get into from the district heating sector, they have an estimate that 10% of the district heating will come from data centers in 2040. And of course, that's a good ambition. And just to make it completely clear from the industry point of view, we are very interested in utilizing as much of the waste heat as possible. Also from the European Union side, you could say some of the requirements that are being introduced now is pushing this development and really forcing us as an industry to be creative on how can we use this waste heat, for example, in the district heating system, but also maybe in other ways. And we can maybe discuss that a little bit further later on. But of course, it's not an easy task. There are a lot of challenges. There are some barriers that we need to solve. And also we experience that in Denmark, there are various reasons why it's sometimes difficult to use the waste heat. And it's not the same reasons everywhere. So somehow we need to address the local differences around the country. We have many district heating associations or district heating companies, and we have many data centers, and each case is really individual and different. But of course, we will try to look into some general things that we can do on a national level together with the district heating association to see can we remove some of the barriers, or could we make incentives to make it more attractive to use the waste heat from data centers on both sides, both for the data centers, but also from the district heating as a company. And also it's of course important and a big ambition for the data center industry to be even more included in the green transition of the Danish society. And to reach that target, we need to be better to couple the sectors, to actually get the data centers involved with other industries, other sectors that are close by. It could be the energy sector, it could be the district heating that we are looking into today. But we really need to engage in closer partnerships and also to find new ways of cooperating across the board. Sometimes you need maybe regulations or policies that can help this development, but sometimes it's also a matter of sitting down and having a talk across these various sectors to see what are the benefits of closer cooperation and how can we promote each other to actually get faster towards the overall targets of the Danish society. We have made this figure that you can see on the right side of the screen, just to illustrate how we think this as a circular economy. You could say you have on the left side the wish for more green power and also the ability to use more data, and this creates of course the developments of more projects within renewable energy that gives us more green power for the data centers. The data centers can supply surplus heat to the district heating, who is then also able to provide heat to both private and also the business customers. So we see this, we are all in the same boat, to say. We all want to have access to as much data as possible. We want to be able to analyze as much data as possible, and that requires data centers as an active backbone of the digital economy. But this has to be done in a very renewable way to make the least footprint as possible. So that's basically what the discussion is all about. And I think I will end my initial remarks with that note. And I look forward to hear the inputs from my three other panelists this morning. So I will pass on the word to Jesper Koch, who is manager at the Green Energy Association and the District Heating Association. So a warm welcome to you, Jesper, and the floor is yours.
Thank you very much, Henrik. I've been looking very much to join you and to give my presentation. How can we together create several good projects on surplus heat or heat extraction from data centers? Because we have, I'm representing more than 380 companies, district heating companies in Denmark, all over Denmark. And I hope that several, or at least a lot maybe of them, will be able to utilize district heating together with your heat extraction or surplus heat. So that is our ambition. And you mentioned 10%. If you take the next slide, then we have together with Aalborg University made and analyzed how much of the district heating can be based on surplus heat from different kinds of industrial units. And I have what you can see in the red areas. It is the amount, the percentage of surplus heat from data centers. Today it's only minor. It's less than 0.5%, I think. But it's, as Henrik mentioned, in 20 perhaps years, it will nearly covers up to, let's say, 10% of the total heat supply in Denmark. And the heat supply in Denmark is quite big. It's around the same energy amount as the electricity deliverance right now. So that's that's a lot of energy in district heating. And what you also can see that it is that in in 20 years, nearly a third part of all the district heating deliverance will be based on surplus heat. And if you count in also geothermal energy, nearly half of the district heating. So we are into an enormous transition, and therefore we are looking very much in first front of district heating together with surplus heat. And I know that we are in green energy will I hope that we in not so many days will start a national plan for how we can stimulate more district heating together with heat extraction, so we can be able to reach our goals. Yeah, if you take the next slide. So how can we manage this? I know there's a lot of things to say. I have 4 good recommendations. If we shall succeed, then number 1, we have to have a good public relation. I have a little bit more afterwards, but it's about taxation and other regulations in district heating. So that's the one, and it has to be better than today, I can say. Then that the other 3, it's much about collaboration, good relation, good transparency between the data centers and the district heating. I would say that it's so important that you play with open cards. You know what the technique are, the economic benefits are for each other, and it's my guess that if there is a total favor in making a contract, you should go that way, and there would be an opportunity to make a contract between the data centers and the district heating, and then you have to, of course, find out how can we divide the cake, so to say. But that is a very important point, that you had to create good relation, and to obtain that, you have to find out what is the culture in each company. And I know that district heating culture is much different from the district, the data center industry. So you have to find out what is the culture. And then I think I would end with a good plan together, make a good plan together. And in that way, I will also say that it's very important that you find out that the economy to connect, can it be based, how far is the data centers from the district heating? So that can be so long distance that it's impossible to get economy in. So therefore, it's very important that there's a not too wide distance between the district heating and the data center. So that's some of that's some of the major factors for succeed with surplus heat. Next slide, please. My recommendation is that normally there's some you can invest. Sometimes it is the industry who invests all the money in the sometimes it's the district heating, but normally when the surplus heat is at low temperature, I think would be the best to let the district heating company invest as much as possible, but then also not have too many restrictions on how the district heating can use, when, how much it should district heating should be utilized, because district heating often has several other production. It can be heat pumps, it can be biomass, And you know, if electricity is probably very high, then district heating will sometimes choose another way to produce. So therefore, it's also for the district heating very important that they have some kind of freedom, so to say, in choosing how they can produce. Well, next slides. I think it's the last I have, because, yeah, next slides, please. I think, yeah. Just a little bit about the public regulation. That's I just mentioned very shortly, because we have a conference tomorrow in district heating in our place tomorrow in Kolding, and we will going to talk a lot about especially price cap, because at the regulation now there's some good things and that's not so good thing. The good thing is that we have been able to avoid taxation on surplus heat. You should only go 5 years back. Then there was high taxation on surplus heat, and it was nearly impossible to use surplus heat. Now the conditions, it's much better, but there is one big minus, that is the price cap. And I know maybe Anders will tell a little bit about it, because I will not go into detail, but a price cap can bring the economy out of shape, so to say. With high electricity prices and a price cap based on historic prices, also on electricity, it's nearly impossible to get economy right now on projects with where you have a heat pump using electricity and utilize, for example, heat from surplus heat from data centers. So therefore, we have to altogether, I would say, we have tried. We have to go further that way to avoid these price cap, because there is already another way where the regulation between in district heating is sound and good, as substitution price it is called, and it's just a normal, what would the alternative price be for production in district heating. So price cap, to my view, it's really not good for project. But more on that tomorrow in our conference. I think it was last slide. I'll just end my presentation with mentioning that I think we shall overcome these obstacles, and then I hope and I think that surplus heat also from these data centers will be a big issue in district heating in the next years. So thank you for letting me having the floor, Henrik.
Thank you, Jesper. And we look forward to also continue our cooperation. We had a meeting a couple of months ago where we had brought together a number of operators of data centers, as well as a number of operators of district heating companies, actually to explore on these challenges. And we try to sort of build some of the arguments together when we talk to politicians and regulators. So we try to speak with one voice, even though our interests, of course, are not 100% the same. But we try to see where have we a common playing ground. So we'll continue that work. So thank you, Jesper, and then we will move on to Anna from Rambøll, who will say something about how Rambøll works with this, but also get more into depth with the example of Meta in Odense, which is one of the biggest cases of utilizing waste heat into the district heating in the world. So go ahead, Anna, the floor is yours.
Absolutely. Thank you very much, Henrik. And it has been great to hear the reflections of Henrik and Jesper, and this is such a key aspect of the entire issue of making use of excess heat, this collaboration between data center industry and the district heating. So very, very happy to hear about this collaboration more in detail. My name is Anna Ekdahl. I work at Rambøll. I am leading the efforts to support our data center clients with all energy related issues. And my background is that I have many years of experience working with heat recovery solutions from the district heating perspective, but also from the data center operation perspective, and in business development as a neutral party between a heat producer and a heat off-taker. And I can say that it doesn't have to be, of course, district heating, but district heating is a very good condition or circumstance that makes heat recovery solutions profitable. And I will now talk about a project of ours that Henrik mentioned, the largest actually heat recovery solutions from a hyperscale data center in the world, which is Meta in Odense. And I hope to inspire you with this and to give you some very concrete recommendations on how to create a good collaboration between data center and the utility in a specific case. So next slide, please. First off, so what is the Meta fjärrvärmefin case? Well, it is a heat pump facility and it is providing cooling to Meta's data center at around 20 degrees. And at the same time, heating to the district heating grid at around 80 degrees. It supplies around 12,000 houses in Odense with heat. And the picture on this slide is from the facility, and you can see the red pipes transporting hot water and the blue pipes transporting cold water. Today, there has been 45 megawatts installed, and there are another 40 additional megawatts in plan. And this makes the largest heat recovery from a hyperscaler in the world. So on the next slide, I will be talking a little bit more about the challenges that the actors were facing. So when it was clear that Meta was about to build a data center in Odense, they were coming from a perspective that they had a sustainability ambition and wanted to know what the business case for heat recovery could look like. Fjärrvärmefin, on their side, the local district heating company, they had a goal to change their production portfolio to more renewable. So as Jesper mentioned, district heating companies often have a mix of production technologies and fuels in their district heating production in a grid. And in this case, they were having a mix of coal, waste incineration, and biomass in the Odense district heating production. So they wanted to switch out the coal primarily, but also see how can we get in more excess heat into our district heating. As was already mentioned, as many of you are certainly aware of, that these are two very different industry sectors that are meeting. And primarily the way that I see it, they are different in the sense of financial logic, particularly in Denmark, as district heating are not allowed to make a profit on their operations. They are very different in the way they handle risk, and they are very different in the respective requirements that they have on time to market. These are factors that are weighed in when there is a business dialogue between a data center and district heating actor. So in this case, the dialogue started early, but the questions were, how do we trust each other? Who should invest in what? And who should control the operations. So and we can take the next slide, and I will describe a little bit more on what then happened, what the solution was, and what we at Rambøll did. So understanding both industry sectors' needs and requirements, Rambøll was assigned to help develop, first of all, a neutral, all-encompassing business case. Second, design and help build the facility. And third, make a strategy for the operation of the facility. So talking a little bit about the business case first, we we developed an all-encompassing business case and to be able to present it openly to both actors, the related costs and benefits for both of them. And in that way, we are laying the foundation to have an open and trustworthy negotiation and subsequent agreement between the two actors. When it comes to the design, Rambøll helped Fjernvarme Fyn, who in this case was decided to take the major investment and also control the operations. So Rambøll designed and helped build the facility for Fjernvarme Fyn. And in the previous picture, you saw the heat pump facility with the data center in the background. So, but we also helped design the operational setup. So Meta always needs cooling. That means that Fjernvarme Fyn, like Jesper mentioned when he was talking about the requirements of district heating, Fjernvarme Fyn can operate the facility according to the optimization of their district heating production. So they can optimize it according to demand, according to other production units, and according to fuel prices. As also was mentioned, as electricity prices are quite high now, of course, that is taken into account. At the same time, Meta gets better cooling when the heat pumps are in operation. That means that they get a lower electricity bill and they get lower OPEX because their cooling machines are running more smoothly and with better temperatures. In turn, Meta has built their facility so as not to be dependent on the heat pumps running. And what were the key success factors in this case to make this happen? So first of all, in Odense, the conditions were good. So also, as Jesper has already brought up before, it's good to be close to a district heating grid, which it was, but the district heating grid was also in need of new production demand. So consider this when you are placing your data center. If you want to have a heat recovery solution, then you need to consider this when choosing your site. The second of all, the actors started the dialogue early on, because even though it's a rather robust and well-used technology, it takes time to get the solution in place and to get to know each other and to build this trust that is needed. Third of all, it was crucial that both actors showed an open attitude. And in this case, they used a neutral party, that is Rambøll, in between to facilitate the dialogue. Because what has already also been mentioned before by both Henrik and Jesper, understanding the business case and understanding each other is really key to get to a good solution for both actors. And then number 4, both actors had a sustainability ambition, because as we said, it's quite simple and robust, but it takes time and it requires some dedication to get this into place. So the question is, what can we learn from this? Well, it can help to have a partner who understands you both, data centers and district heating companies. You need to understand the business case from both sides. And third, it can be a very good idea to use a partner who can help you through all these aspects, the business dialogue, the technical design, and the operation. And I expect you to ask yourself, in this case, is heat extraction something for me? Well, if you, first of all, have cooling machines and not direct air cooling solutions, then yes, you have the technical solution or opportunity to look into this. And if you're not placed to close to a district heating grid, which would be the optimal way, you should still not discard the idea, get in contact with a direct off-taker or a third-party actor that can connect you to an off-taker outside the district heating grid, or take help of someone, an actor that has good knowledge of these kinds of solutions and the industries. That was what I wanted to send. I hope that it has been something, some key takeaways from this example that you can bring forward with you. And I will hand over to Anders and thank you, Henrik, for giving me the word.
You're welcome, Anna. And thanks for getting into also to some of the issues with regard to the investment, who is taking the investment, also the business condition, the business model for this cooperation, which I think is crucial, and of course also the distance and the location of the data centers, where we can say some data centers are located already where they are, and we have to see how can we work with them to use as much as possible, and then in the future we can look more into actually strategically perhaps locate data centers closer to the district heating companies, so it's easier to implement these projects. But thanks for your input, and we will move on to Anders Mathisen from Global Connect, who is also familiar with utilizing waste heat, their facility in Høje-Taastrup. So you have the word, Anders.
Thank you very much, Henrik. And yes, I am. First of all, my name is Anders. I'm the director of both operations and projects in Global Connect, which means I oversee both our 17 live data centers and also our 5 outbuilds currently ongoing of data centers across the Nordics. We are here to talk about a project that was done in Taastrup, but also want to just refer to, we were already doing this in one of our Sweden data centers, and we have an agreement to also do it in a Norwegian data center as well. So I've not prepared a large presentation because this also shows a little bit about the pragmatic way that we did this in Taastrup. We actually did what Anna said. We need to have a relationship. So I sat down with, you can see the picture of Astrid here, who's the CEO of Taastrup Fjernvarme. We sat down, have a look at each other, and I see, is there something we can do here? And there was. Then we just start talking about how do we do this? Do we start squeezing the lemon, or do we actually see how do we share this and how do we actually make this happen? We had a few talks back and forth. What was the interest for us? And I think we both agreed that the main interest was to give something to society. So that will be the green and sustainability way forward. So once we agreed on that, we need to figure out how do we do it then. I looked at my operation, she looked at her operation and said she actually just wants any heating that she could get. I basically just want to get rid of any heat I could. So we were in the stage where, do I want to get greedy and start saying, I want to have a certain amount of money for any heat I give up because it has a value for you? Essentially, it doesn't have a value for me. Any heat that's in my data center is a cost to me. So we sat down and looked, and I don't have a value in this. I can give it up for free and it can create value for you. And then she would have it for free. That means that she would also be the one that would actually put value to the heat. So we found it was fair that she did the investment. What is always going to be happening once we do investment like this is try to look at risk and outs. How do you get out of it? So we agreed that we roughly thought that this would take about a 10-year payback. So we shook hands and say, if anybody of us wants out of this deal before end of the 10-year payback, we have to pay the remaining costs for the project that hasn't been written off yet. That was a fairly good agreement. So we shook hands on and signed a contract. So now we're in a place where we're not live yet. We're going to go live in a bit now. People say this is a worst deal ever made because of the electricity prices. And it's basically they can't take any heat out because it costs them more. But I think once we had a sit down and we made a simple as possible contract that we could, we didn't put KPIs or SLAs in saying she had to take that much heat or I have to give at least this much heat in these periods. We are very flexible in the setup like this. So we can actually say, oh, right now it's not feasible to run this. Okay, we'll just have it stand by for whenever it's feasible again. And nobody's hurt from it. We're not breaking any contracts. We're not looking about who has to pay for the energy prices going up. Essentially, nobody does. But now we have this in the backhand for whenever it's feasible to run again, we'll start it up again. And she will get free heat if you look besides the capital cost, and I'll get free cooling. So I think we try to put this as an example as how simple can it be done. I know that Anna, you were not in the same position where You couldn't just sit two guys, a guy and Astrid, me and Astrid at the table. You had a large American corporation that you need to incorporate into this. And also Fjernvarme Fyn is quite a big Fjernvarme company. So you might not have the same possibilities that we have. But as Jesper said, well, I can't remember the actual number, but hundreds of different Fjernvarme or district heating companies around Denmark at least, and also in the other countries in the Nordics. There should be at least a good handful, if not multiple handfuls, of places where a corporation like we did is possible. Look each other in the eye, shake hands, see we want the best for our sustainability growth that we both want. Can we make this happen? And again, it might be a bit prerogative, but don't be greedy in these cases. It works out, you get a benefit, don't be greedy, you want to squeeze the lemon, share it instead, make some lemonade and share it between the two partners. And on this, just to reach, we'll install this in, I think a couple of months, we'll have it up and running. But this has also turned out that I've been contacted with other district heating companies, and we're trying to do the same thing. Sit down, have a talk, see, is there anything we can do here that benefits both of us? And not look at having equal slices of cake, as long as we both get cake. And that will be the word for me.
Thank you very much, Anders. It's great to hear that this can be solved over a cup of coffee, which is great in many instances. So it's a good to have, I say, both sides. Because I think also one of the questions that we will touch upon is how much heat do we need to deliver before it's relevant for the district heating company? I mean, are there any lowest amount that can be accepted from the district heating companies? And I think these cases illustrates that varies. Some district heating companies will probably require a good amount before they will make an investment, but other places it will be possible also with a lower amount of heat. So I think it's important to get all these cases out in the open. So thank you very much, all of you. We are getting a number of questions I can see in the Q&A, so we will hurry on, starting to see if we can answer some of those questions. And let me start out. I think that would probably be for you, Jesper. It's Elliot Moore who is asking, I heard that data centers are at the bottom of the heat hierarchy, and therefore it's difficult for data center managers to have certainty that their heat will be used. Is this true? You just need to unmute, Jesper.
Better now? Yeah.
Yes.
Yeah, thank you. Well, of course, temperature is high temperature is better than low temperature in district heating. Of course, because, for example, if we use a heat pump, the efficiency of the heat pump will be much higher, and we will use less electricity to produce district heating. But 30 degrees, 35 degrees is still very good, and I don't think it's of course it's depending on prices, but it is much better than alternatives for a lot of district heating, where they have heat pumps based on air, outside air, and you know, in winter where temperatures go probably below zero, and at that time you have a lot of need for much heat, then heat-based heat pumps are not very efficient, and therefore it's much better to, and I'm certain that a lot of district heating will gladly use surplus heat from your data centers, especially yours. Yeah. So, of course, it's always a matter of what is the price for each production technology. as Anna also mentioned. But I'm rather, it's a special situation right now with extremely high electricity prices. I know here today it's more than 4 Danish kroner per kilowatt hour, and I don't think many heat pumps will run today because that price is very high.
Thank you, Jesper. Then there's a very concrete question on, could you please give an overview of how many Danish cities working with district heating infrastructure already? Well, most cities have district heating infrastructure. If the question goes to which cities are already involved in data center surplus heat coming into the infrastructure, the answer is, well, some of them, it's Odense, of course, from the Neta example. It's Esbjerg beginning with some heat from Bolt. It's Viborg, who is beginning to cooperate with Apple, and there will be surplus heat within maybe a year and a half or so. Albertslund has an agreement with Penta. Silkeborg is working with JN Data. Høje-Taastrup, of course, with Global Connect, and also Nordea, and more coming in the near future. So those are some of the cities that are already involved in these types of projects. But if it's an anonymous person who asks this, but if it's someone not familiar with the Danish situation, we can say that district heating covers a very large part of the heat supply in Denmark. I think it's 65% or something like that. So it is installed in all major cities. So I hope that was an answer for that. Then there's also a question for you, Anna. You mentioned this topic of distance and the location of the data center, and there's a question on if you can give sort of an overview on what is the maximum distance that should be between the data center and the district heating facility.
That's a question that pops up often, and it's hard to say give a clear answer because it depends on the volume of heat that is produced. So, are we talking a small data center? Of course, it would the investment in the pipe to transport the heat from the data center to the district heating would need to be justified by the volume of heat that is transported. So the smaller the data center, the closer it needs to be, the larger it can actually be quite some distance. There are also some transmission nets, both in Denmark, but also in other Nordic countries that transport district heating quite far. But would I dare? So maybe Jesper wants to add on. Would you dare to give a number of a distance?
No, you're quite right. I would say it. Of course, it's the heat pump. It's the heat pipelines that is the most expensive part of it. It can easily be several millions per kilometer. But it's, of course, if it's smaller, it's cheaper. But then it's not produce so much heat, or there's not so much heat in it. But what is important for district heating? It's not alone, of course, the investment price, but also how many years you can afskrive. You can pay the Yeah, and today the regulation is it says maximum is 30 years, but we are working on the next regulation that this will be, and I think we will succeed, that we can maybe get this number up to 45 years, and therefore it more possible to invest in pipelines, in expensive pipelines, because in real life, pipelines last for, we have seen, more than 60 years. So 30 years is much too low compared to reality. But that's not the case right now, but that's a policy thing we are making right now. Yeah.
Thank you. We have a question a little bit back to what you mentioned, Anders, with the agreement and the business model between the district heating and the data center. The question is, what happens if Meta for some reason has to close down the data center? Did Meta and Fjernvarme Fyn make an agreement for a fixed amount of years? Has Fjernvarme Fyn thought about a backup plan? I'm not sure you can answer that, but let me hear. And maybe Anders, you can just elaborate a little bit also on the agreement you have made.
Yeah, very good questions and relevant. I cannot disclose any details about the contract between Meta and Fjernvarme Fyn, but in general, of course, you have the possibility that Anders mentioned for Global Connect to say that if you have a payback period, if the data center would move or close down before that they will be required to cover a part of the cost. There's also the possibility of handling this risk in the business case itself and make sure that the payback period is the length that you want, and also prepare include in the business case a preparation of adding an additional or supplementary heat source instead of the data center if it would disappear. Like Jesper said, there are quite some heat pump facilities being built today in the district heating grids that are reliant on other sources of heat, such as air or geothermal heat or other heat producers. So there are a number of options. Anders, please.
I can elaborate a little bit.
Yeah.
I think also there's a bit of difference in which kind of data centers you are using for this, because I think enterprise data center like Meta or Google, they are quite agile. If they want to shut down and move away, they can do it within a very short period of time. The co-location business that I'm in, we rarely see data centers move. And it's because there's a lot of cost and a lot of contracts need to be negotiated if you have to move a data center. So if you go in, you see probably people moving into data centers, they will stay there for maybe 10, 15 years until company shuts down and wants something completely different. What also is worth looking at is that in a data center, you have a huge electrical infrastructure. So you also have quite a large transformer, quite a large amount of incoming power into that place. Meaning if the data center are to move, then a company who would be willing to move into those locations would be a high demand energy company. And I cannot think of a company that uses energy that does not have waste heat or a surplus of heat, whatever we want to call it in this case. But whenever there's electricity, there's almost certain to come a heat product that's not being used at the end of that. Which gives you safety into the business case. Sorry, Anna.
No, thank you. I think it's a really good point that you're making, Anders, also to mention that this risk, to make, at least to have a proper evaluation of the risk, because a data center is a big investment. It's not easily closed down or moved just because. I mean, it will have serious implications if you would close it down, because it is a major investment. So it's not something that is a high risk as such.
Yeah, so they will stay there for a long time, most likely. Yeah.
Well, also mainly because we have in Denmark a fantastic electric infrastructure, and you have green power, high certainty on production and electricity. So we are maybe I think number 2 in the world of stability on electricity, and it also green, more and more green. So I think it will be quite surprising if you will see companies move away.
Yes, there's a question maybe a little bit more to you, Jesper, with regard to the temperature level, which is also a matter of the investment, because there's a certain temperature that we can deliver at the moment, and you have to receive this this heat at a high temperature. But there's a question: when can we expect to see real projects in Denmark where the supply temperature from data centers can be lowered to 45 to 50 degrees as technical possible today? So I think it addresses also the development of the district heating, that you also start operating with lower temperature in some systems.
Yeah, we are on that track. A lot of companies, district heating companies, on that track, working with how they can reduce temperature in district heating, and now, for example, one of the issues is that there are a lot of companies now using digitalization much more. So how can they find out where is the buildings with needing too high temperatures, and how can we manage them? Because normally the problem is in buildings, not in the district heating. So if we have, for example, old buildings, could it be have demand for 65 degrees, 70 degrees in radiators, then it's very difficult. But the district heating companies can work with, for example, sectionating parts of the network. So there's some different kind of way that where district heating are going to in the future have a bit lower temperature. I will say that I don't know how much they will 60 degrees, maybe a little bit less, and then we will see some and more new district heating companies we know where they have some cold district heating, and then you use a heat pump in buildings instead. That could also be a solution, or very low temperature heat in temperatures in the pipelines. So we definitely on that track, and then I know that in data centers they will in the future, I hope also they will use water cooling, so we maybe can avoid heat pumps in some cases.
And I would love to add on to that, Henrik.
Yes, please.
Previously, I worked building these kinds of district heating. This district heat, cold district heating or medium temperature district heating, and it is definitely growing. It's a growing area, and either use it colder temperature and distributed heat pumps out in the system, or out that with the buildings that are connected to the grid, or a medium temperature like 60-40 degrees in district heating temperature. And there are this is also what I mean when I before referred to third-party actors. So it doesn't necessarily have to be the local district heating company. It can be a third actor that comes in and actually builds a system around a heat source, such as a data center. And that kind of projects was what my team was building before. So that's my experience, and that is relevant across Europe. So it's not only Denmark we're talking here. I mean, it's relevant in all parts of Europe where there is also not such a big footprint of district heating as there is in Denmark.
Yeah. We have a question with regard to the price cap, Jesper. Jesper presented that the price cap was a negative thing, yet Anders has stated any heat inside his business is either cost or at least without value. Perhaps Jesper can expand why a price cap is a bad thing.
Yeah, I will try. Yeah, that's, as I mentioned, we have in a lot of years have another regulation called the substitution price, where that's just like in normal industry, where you give the price that is relevant compared to alternatives. But this new price cap, has been very fine if it has been on the surplus heat, but it's not. It's on the deliverance from the district heating side. So what the Danish Energy Agency does here is that they say, okay, you have the price for the surplus heat, then you transform it, for example, through a heat pump, and you have investment as well. And when you have all together, this total price cannot exceed, today it's 77 Danish kroner per gigajoule. And you know how they set the price of 77. It will be a little bit higher price next year. It's mainly based on historical prices on electricity, and then you have some theoretically data from a technical catalog, they say it in Danish Energy Agency, where you have investment in heat pump and in biomass, and then you make a calculation. What would the price cap be on a base of full load hour of 6,000 hours and some and investment? And sometimes it can be fine, but especially now with high electricity prices, it's unable to be below 77 Danish kroner. I think you just today 4 Danish kroner. It's it's so high that even the electricity price is higher than the price cap. So, and of course there's some doors out of this in the regulation, but it's so stupid, this price cap, that we have the uncertainties with the price cap, which has some kind of reluctancy, or you're not become a little bit uncertain of, is it a good investment, this in surplus heat? So I hope it was an answer. But we have much more on this topic tomorrow in our conference in Kolding in Fjernvarmens Hus.
Yeah. There's a question. Maybe you can answer this, Anna. How much of the used energy in the DC is recovered in Odense, and how much electricity is used for increasing the temperature of the recovered heat? I guess it's a question of how green is the case. How big share of the energy can we actually use twice, so to speak?
Good question. I don't know it. Since it's an operating model where Fjernvarmen is optimizing according to prices and other production units. It fluctuates, of course, with the high electricity prices. I would also suspect, like Jesper mentioned, that the heat pump is not running today, for example. But maybe I will be able to get some information and send it to the person asking if that's of interest. But otherwise, of course, it's the numbers that I already mentioned with the 8 to 5 megawatts. And the question is how many hours per year that this capacity is actually running. But I'd be happy to look it up and get back to the person asking.
Super.
I think it's the end of the time. I unfortunately have to go to another meeting, but I want to thank you all.
Thank you, Anders. Thank you for your participation.
Thank you.
Then there's a question with regard to the carbon emissions. How do you split the carbon emissions from a corporate reporting perspective? Do you consider the heat as emission free, or do you share the emissions between the electricity and heat? Is that something you can answer, Anna?
Not
No.
from the top of my head, no, I cannot. But it's an interesting question. But so of course it depends also on usually you would combine it with the green electricity with low or zero emissions. But no. But I'm happy also to look this up and get back to the person asking.
Maybe I can give it a little. I'm not fully certain, but I think because when we work with the authorities, also taxation authorities, about this taxation, then we convince them when you produce surplus heat and you make the best effort, even if it's coal or natural gas, then surplus heat is without CO2. And therefore, that was the reason for the authorities said that, okay, then there's no taxation. So there's no energy taxation, no CO2 taxation on surplus heat anymore. Of course, it's only in these cases where if you use fossil fuels where there's no extra use of energy. But when we come to electricity, they have defined it that electricity in that matter is CO2 free. So I will think that it will be quite surprising if district heating had more than zero. It's not. I would say zero but I know that, of course, electricity for the company from data centers, that will be the normal mix, or otherwise you have to buy certificates for electricity production, electricity using.
Just running through the questions. One question that I would like to also touch upon was the one we also had initially, where we talked about that. Of course, it's obvious to try to use as much heat as possible into the district heating association, but there are also other ways of using this surplus heat. So maybe Anna from Rambøll, can you explore a little bit on other things that you can actually use the heat for?
Right. Yes. So I've been working around 10 some years with heat recovery solutions from data centers, but also from other industries, and of course there's the potential of having a direct off-taker, so that you have someone that needs heat in your vicinity or close to your site, that you transport the heat to directly, and that could be also low-grade heat. So industries, other industries that a lot of people are thinking straight away on will be greenhouses or aquaculture and industry like this. But a lot of industry needs heating for parts of their processes, for heating the facility as such. And so there's this direct off-taker potential. And then, of course, what we touched upon before with Jesper, when you build what would typically be referred to a fifth generation district heating. That is the new technology coming into district heating, where you distribute lower temperatures and having the potential of also having a much cheaper distribution system. Like Jesper mentioned, that it's a big cost related to actually putting the pipes in the ground. But if you have lower temperature in the pipes, this investment goes down significantly. And then to distribute a low heat and then have heat pumps out in the different buildings that are using either heat or cooling, and you can also balance it. And there are a number of actors that are specializing on these kinds of solutions. So and it's a growing area, and it's going to come more and more. So that's also an interesting possibility.
Yeah. I think we can reach one more question. Actually, also interesting, I think, maybe for countries that don't have an existing district heating network. There's a question, sounds like this: would a heat supply from a data center ever be an incentive to build a district heating network? Or is it only ever worth considering if there is already existing nearby district heating network?
Yeah, exactly.
That's a good question.
Yeah, exactly. So I mean, that would be directly connected to the types of solutions that I mentioned just now, and so of course, if you would actually build a system around the data center, then you would need to know that the data center will be there for a long time, or it is not the only heat supplier into the grid. So there are actors and solutions that definitely would build if there is both a heat demand and a heat supply in an area from various actors, amongst them data centers. It could definitely make sense to build a new district heating, specifically a low temperature district heating system around such a group of users, off-takers and suppliers.
Yeah, and I think that poses some export opportunities from the Danish experiences, Jesper. If other cities or countries are looking into this combination of surplus heat and district heating network.
Yeah, that's definitely what we hope, that these different kind of example, as Anna mentioned, also these low temperature will be possible to export that kind of technology. But I know that I'm totally agree with Anna that it could be maybe easily done with these fifth generation or low temperature district heating, but no, I'm a little bit more uncertain about when if you will build a new district heating only based on surplus heat from data centers, because in the heart of district heating there will always be this: how can we ensure always to deliver cheap heat to the customer? And normally you will have a variation of technologies and a mix of fuels in your system, and that's why we have been able in Denmark to avoid these very high price rising in district heating. That's because electricity is high, natural gas is high, then we use surplus heat or biomass or other kinds of fuels. So that's in the heart of every district heating manager.
So just to finish off the session, just one question to each of you with regard to the next steps, in your opinion, if we have to accelerate this development, what should happen in the next 2-3 years to have the best possible environment for these types of developments? Maybe you first, Jesper.
Yeah,
and you only have 30 seconds.
Yeah, first of all, I think it more knowledge about it, and when we have talked about this, how can we make mapping? Where could these where can we have these stations? Where with these solutions? That's the one, and then we are looking into maybe a national strategic, because we have not only data centers, but we also power to X stations and other new kinds of big producers of heat, who we are a little bit interested in what could be the right mix for the district heating. So on a short, let us make the map.
Yes. And Anna?
Yes, absolutely. More knowledge and information is key. from a district heating definitely could be preparing and being able to tell, like, where do we need the heat to be able to communicate this to the market, and from the data centers to open up and have the dialogue, because sometimes it can be, there are some, the way from my previous discussions, there are some misconceptions out on the market on how you can connect, what kind of heat you can use, the distance, these questions that have also been popping up today. So make sure that you actually know, or take help from someone that does know. So that's my message.
Thank you very much.
Mm.
And we have run out of time, so I want to thank you very much to both Jesper and Anna, and also Anders, who had to leave us a little bit early. And thanks to the audience for a lot of good questions. It was great to have the dialogue. I hope you had some good inspiration from the last hour or so. And I wish you a continued good day, and of course a good result for the Danish football team in the afternoon, so we can all have a good evening. So thanks a lot for participating. And
Rick, can I just, will you just send over the questions that
yes,
we couldn't reply directly today, so we can get back to the participants? Yeah.
We'll do that.
Perfect.
Thank you very much.
Okay, thank you.
Thank you. Bye.
Bye.
Bye.